Hello, this is an introduction to Catena Space, how we're involved in Hatch and how we might use Hatch as part of our business activities. My name is Tanya Boardman and I'm a director of Catena Space. We're a small company based in the UK and we're coming up to our 5th birthday, although the team has a much longer experience of working in the space sector. As part of the Hatch consortium, Catena was involved in creating the concept of Hatch and in the delivery and implementation of those ideas to make the portal that you have here. One of the frustrations that you have in a small business, that we certainly have, is not having enough time, especially in finding information that you know exists. And that is essentially the reason for creating Hatch, because it was difficult to find, simply and in one place, information about research and innovation in space. This is something that we use as a small company when creating training material or researching for other project work. But it's a need that many different types of people have, from those working in larger companies or doing their own personal research. If you can find the right information easily and quickly, it certainly makes for a better day. We run training courses, and I'm going to spend a bit of time talking really briefly about space missions, which is one of the topics that we teach people. For me, the phrase space mission conjures up big rockets and human spaceflight. But what most space missions involve, in reality, are satellites. Satellites that do the work to help us communicate, navigate, and observe the Earth from a really high viewpoint. The term space mission refers to the whole program. It's not just the more visible public face of launch, but starts with the idea of the mission and the planning and lasts until the spacecraft or satellite is taken out of orbit so that it doesn't add to the space debris that can damage other spacecraft and impede other missions. A couple more definitions. Mission operations are the activities used to manage and communicate with the spacecraft. Think of the rooms with many screens, usually quite dark, with not many distractions that you see in the movies. There's a lot of data involved, but it's still a people-focused role. Operations are designed into the mission plan to ensure that objectives are met. Access to space could be interchanged with the term launch, but also it's more than a big blast of flames that you might see on film. It covers everything that's needed to get your spacecraft from Earth to the right place in space in order to deliver the mission objectives. So this diagram represents what's involved in a mission, and I usually start at the bottom right-hand corner with the mission concept and the ideas and the objectives for what the mission is needed to do. Once you know this, you can work out the launch element, where and how you're going to launch your spacecraft. You need to know the orbit and the constellation, where your spacecraft is going to be, and is it going to link up with any other satellites. The satellite itself is made up of two main components. The structure or framework of the satellite is known as the bus, and the payload is the instruments or humans that are needed to deliver the mission. The communications architecture describe how the satellite will communicate with the Earth through the ground station, and this is managed in the Mission Control Center and Operations Center, which determines what information and data is transferred to the satellite and received from the satellite. Data received from the satellite is then processed, archived, or disseminated to the users, and the users in turn have an impact and input to future missions, especially in the more commercial world of space that we are in the middle of now. So how do we find out about the latest research into space missions, who's involved? And this is one of the reasons why we have created Hatch. So you can search in this main box here for space missions. And it can come up with some different projects that we can see. So, for example, Astrobiology and Space Missions Road Mapping, where we can see a little description about what the project is, the funding body on the right hand side, and we can see the participants. So if we need to contact them or we're looking to find out more information, we have a place to start in order to find out more. And if I don't want to do that immediately, I can add that to a network. In fact, I'm already following that in a network, so when I need to return to that, it's much easier for me to find that. So in order to access space, what happens? As I've discussed, launch is one aspect of the mission, and it's important to send your spacecraft or satellite to the orbit where it can best perform the mission objectives. The launch strategy will be dependent on and specific to the orbit, and the orbit will be determined by the mission, the altitude and speed of the spacecraft, how often and what type of communications are needed to deliver the mission. So again, we can refer to this diagram and see that it fits in as a crucial part of the mission, and it's not created or defined in isolation to other aspects of the mission. An orbit is a path that your spacecraft takes travelling round, in most cases here, the Earth. And it's described by 6 parameters, which describe the size, the shape, the orientation of your satellite in relation to the Earth, and also the exact position of the spacecraft as it's travelling around the Earth. And if you change one of these parameters, you'll change the motion of the spacecraft and affect its ability to deliver the mission. So this diagram shows the different parameters to describe the orbit, how they relate to each other, and you can see that it's in relation to the Earth and to the equatorial plane. So again, we can look in Hatch for interesting and latest research. So if I look in networks to start with, I've already created a launch network which has some projects in there, some interesting articles, organisations that are involved. So whenever I need to know something about launch, if I find something new, I can add this back to my network. There may be some networks that other people have created that are relevant, so I know there aren't huge numbers at the moment, so I can easily browse the networks. And there's one here on space propulsion, which is probably of interest. And it's just got one project in there at the moment, but I can follow that network also, and then when things are updated, I'll be alerted and I'll be able to see if that's useful to my work. The other thing I can do to help me understand orbits is perhaps see if there's some quick knowledge available which may help me understand how to describe the orbit or a little bit more about it. And there is some quick knowledge, which is a more visual content, and some shorter words, which make it a bit easier to explain all about orbits. So again, I can save that and return to that later if I need to. So I don't want to worry you, but from the ground, we don't always know where our spacecrafts are. If they're not in direct communication, the position is estimated based on a number of calculations and then checked when it's back in range. Space is a harsh environment, and there are many things that can affect the movement of a spacecraft and mean that it's not always exactly on the path that's predicted. Space weather, including solar sailing, is sometimes used deliberately to move a spacecraft, but it can also act independently, and photons from the sun have a really small but really persistent force on the spacecraft, which can alter its position. The atmospheric drag will slow down the movement of the spacecraft. Magnetic interference can affect the spacecraft systems. Gravity will pull the spacecraft towards the largest body in the vicinity, which is usually a planet or a moon, and can also be used deliberately to change the path of a spacecraft. And through operations procedures, the position of the spacecraft is checked, known as tracking and ranging, and this uses a series of signals bouncing back from the spacecraft to calculate the exact position and feed in to make estimations even more accurate. Other communications used in operations are known as telemetry, which is the data downlink from the spacecraft and includes data and information from your payload, but it also includes housekeeping information, which is the status of your spacecraft. Are the systems of the spacecraft doing what you expect them to be doing? Is there enough power? That kind of thing. Telecommands are instructions that travel from the Earth to the spacecraft, and these instructions may be implemented immediately, or they can be time tagged to be actioned at a later time, perhaps after the pass has happened. And this is important because not all spacecraft are constantly in communication with the Earth. So if there's a big period of time when they are out of communication, there may still be actions and tasks that need to happen, and these can be programmed in using time-tagged telecommands. So our time here is coming to an end. So a quick recap to remind you that we have described a space mission. We've learnt a little bit about what operations are and some definitions and explanations. And we have talked about the importance of launch for achieving mission objectives. And there's been a couple of demonstrations of how Hatch can help you in your work, in your study, or in any other research that you might be doing.